You're welcome. So thank you very much to everyone to give me this opportunity to join this wonderful seminar. And Professor Ulas Akaros has already introduced me, I guess perfectly, so I can just start. My presentation will be on seafood fraud incident control and histological methods to be applied for the discrimination of fresh and thawed products. So first of all, what's freezing and the effect on seafood quality? Freezing is one of the most common methods for seafood's shelf life extension and long-term preserving in fish industry. The preservative effect is expressed by the subtraction of water through the phenomenon of crystallization. During the process, depending on the freezing speed and temperature, the formation of intra and extra cellular micro and macro crystals can cause significant microstructural changes, affecting the water holding capacity and increasing the spoilage rate of the thawed product. This aspect has a tremendous and direct impact on the consumer's perceived quality of thawed product, and of course as a direct impact on the product commercial value. Thus, in order to protect the consumer's interest and safety, pursuant to specific regulation, a European regulation on food and seafood labeling, the freezing occurred and the freezing date must be indicated among the mandatory information for the correct labeling on fish products. The lack of such indication, in addition to lead to non-compliances, can favor, of course, commercial fraud phenomena. This said, the implementation of analytical methods, specifically addressing the discrimination of fresh and frozen products, is needed. Speaking of that, among several approaches, histology has been recently reproposed by virtue of cost effectiveness and the potential automation of the technique. And several official laboratories in Italy are now applying it as a tool for the official control in this kind of substitution. The main method limitations are represented by the usability of the method that is still linked to specific expertise of the laboratories, and the fact that the procedure at present is not applied by food business operator as a self-control tool. But speaking more in detail about the technique, it is an analysis that is aimed at seeking the alteration attributable to freezing caused by exactly the formation of these ice crystals that I was mentioning before within the muscle fiber cells. The analytical procedure is conducted as a standard histological protocol for tissue processing that ends with the staining of histological section, generally with hematoxin and eosin, and the further comparison of the histological pattern of the sample under study with reference histological preparations belonging to frozen and fresh tissue. But which is the factor that, that have a major role in the design of the method. First of all, we have to consider that the microanatomy of different species is significantly different. So different species have to be evaluated separately or accordingly. And the presence of alteration determined by the autolytic phenomena or microbial overgrowth during the shelf life of the product can interfere with the correct assigning of the product to fresh or frozen. And then the analytical procedure itself can determine the appearance of alteration that can be confused with those induced by freezing. And finally, the setting need to lead to a standardization of the method so that the parameters that are used can be applied and the protocol that is finally validated can be used also in ring tests among different laboratories. This considered the aim of the research that I would like to present you was focus on the developing on standard method and on operational protocols applicable as tool for self-control or official control by competent authorities to discriminate fresh and frozen seafood products in order to monitor the supply chain at every level. So also to at the level of the suppliers and large-scale distribution. And secondly, technically speaking, the aim was to offer standard parameters readily evaluated even by non-expert but specifically trained operators. I would like to introduce you two research outlines that we followed. One on the discrimination of fresh and frozen whitefish products on the model of Merluccius merluccius, and the other one on the model of Octopus vulgaris for the discrimination of fresh and frozen cephalopod products available on the market. About the analytical setting, you will see that we prepared the study in two steps. The first one was aimed and focused on the preliminary descriptive analysis to evaluate and study the tissue macroanatomy of that category, and then select the elective sampling site to be studied, and evaluate the presence of time-dependent tissue alteration that could, in a certain way, alter the right interpretation of the further comparative analysis on fresh and frozen samples that was set to verify the applicability of certain selected morphological and morphometric parameters that were indicative of freezing. These to define a standard protocol for the analysis of any analytical histological section. So starting with the first model, Merluccius merluccius, and going to the preliminary descriptive analysis, the first part was made by the analysis of fresh exemplars that were collected within the first 24 hours after fishing. The descriptive analysis of the microanatomy was conducted on 3 distinct sampling sites, and specifically the one laying around the lateral line, a second one on the dorsal muscle, and the third one on the ventral muscle. From the analysis, sorry, I don't know what's going on. Okay, from the analysis, the histological section highlighted the presence of 2 different muscular fibers types that were represented by large polygonal fibers whose cytoplasm was packed with myofibrils, and small myofibers whose cytoplasm was often showing several small round empty spaces corresponding to lipid droplets that could lead to a misinterpretation of the histological section during the comparative analysis. Thus, in order to standardize the muscle section analysis, the dorsal muscle in which the small myofibers were less frequently highlighted was finally selected. Then the occurrence of time-dependent tissue modification during fresh tissue shelf life were evaluated and characterized mainly as histological focal areas of either swollen, shrunken, or fragmented fibers recollected to enzymatic autolysis. All these alterations were excluded by the list of candidate morphological parameters for fresh versus frozen discrimination. Then going to the real comparative analysis, this was conducted started from 30 fresh exemplars that were collected within 24 hours from the catching, that were sampled and then frozen in a conventional freezer, just to mimic the domestic freezing condition, and were left there for about 15 days. The analysis was completed by the purchase of 30 more frozen samples that had been previously frozen at industrial level. About the selection of morphological and morphometrical parameters, so countable and measurable parameters. First of all, we selected the one that were describing the morphological macroanatomy of the tissue, and were represented by the overall muscle structural organization, the myofiber vacuolization, and the interstitial proteinaceous, the presence of interstitial proteinaceous material that were already well described in previous studies. And another parameters, the morphometrical one, was represented by the measurement of the vacuoles area in the compared to the spot areas included in each section, and it was calculated as a ratio and a percentage of myofiber area occupied by the vacuolization area. Passing briefly to the result, first of all, about the overall structure organization, it was clear that it was significantly, the overall structure organization was significantly affected by freezing, the application of the freezing procedure. And it was noticed that the conventional freezing, so the domestic one, led to a highest degree of destructuration. So why we pose this question? Because possibly since the destructuration is strongly related to the freezing procedure applied, the conventional freezing led to a prevalence of macrocrystallization phenomenon and a cellular dehydration and breakage of the cellular membrane during the thawing procedure, causing this pattern that you can see in the slide. About the other two morphological parameters, the myofibers, vacuolization, and the presence of proteinaceous materials, in all the frozen samples, it was highlighted in a very high percentage, up to the 100%, considering the industrial freezing. And this aspect highlighted that both parameters had to be considered as significantly freezing dependent and had to be included in the final protocol for the discrimination. About the morphometrical parameters, they were used to establish a cutoff limit for the discrimination of freezing that was calculated on the mean number of vacuoles per area analyzed and corresponding to 1 vacuole per area. It meant that if I was considering a section, I had to visualize it and in 4 areas to find out at least 1 vacuole. This is the final operational grid that we produced, and that was further administered to 2 distinct operators for the reclassification trial and the final blind test for the validation of the method. As you can see, all the parameters were included in the grid. The 2 distinct operators involved in the trial were represented by 1 expert, a pathologist, and 1 in training that was a student. And the 2 tests conducted were aimed at establish the sensitivity, specificity, and operators concordance, and to proceed with a final validation conducted by a blind test on 30 additional commercial samples that weren't being analyzed before by the 2 operators. Speaking about the result of this final validation, the reclassification trial offered the opportunity to underline a really high sensitivity and specificity of the method and a significant analytical concordance between the 2 operators. And the blind test confirmed the 100% efficiency of the grid that was prepared during the study. In conclusion, the selected histological parameters and the final operative protocol applied to the European ache, the molluschus, may represent a reliable and cost-effective procedure to be proposed for the analysis of whitefish category, and the procedure doesn't specifically require a long-term expertise to be applied, since the student reached the same level of specificity and sensitivity of the expert, just training himself in the use of the operational grid. Let's go in briefly and quickly to the second model, the one on the analysis of fresh and frozen cephalopods on the model of Octopus vulgaris. As you can see, the approach to these metrics changed totally because both mantle and arm in cephalopods are edible, and we applied the study in a parallel way, analyzing both the tissues. About the mantle, two different dissections were applied, one transversal and one longitudinal parallel to the longitudinal axis. About the arm, only one section was considered, the one that was transversal to the longitudinal axis of the arm. Before going ahead with the description, here in this slide, I put a quick description of what is the anatomy, the microanatomy of the mantle in the transversal on the left, and on the right in the longitudinal section of the mantle. And as you can see, you can observe a multi-layer tissue that is confined by two connective tissue layers, and in the middle is represented by different muscle bundles going in different direction. And for the purposes of our studies, we finally selected the longitudinal section that was the one that guaranteed us the visualization of all the three directions of the muscle bundle. About the arm, we considered both the muscle area and the axial nerve that were all included as the microstructure to be analyzed for the further comparative analysis. Going straight and quickly to the comparative analysis, it was conducted similarly to the one on Berluccius. So we sampled both fresh exemplar and frozen exemplar, and we prepared ourselves the experimental frozen samples, mimicking the domestic freezing of the product. Differently from the other, you can find two different categories that are represented by the industrial frozen after tumbling procedure and fresh tumbled tissue. So what is tumbling? Because maybe you are not familiar with this procedure. Tumbling procedure or curling process is an industrial procedure applied specifically to cephalopod to tenderdize their tissue and their muscle tissue by breaking fibers cross bonds, and is applied using automatic tumbler that rotate at a varied speed. And the procedure include the addition of a 3% sodium chloride solution and a 30-minute washing after the manual evisceration and peeling of the tissue. This tumbling procedure is applied both to the fresh tissue and the frozen, thawed, and refrozen tissue. That's why you can find different, the industrially frozen tumbled and the fresh tumbled tissue. Speaking briefly about the assessment of the histological parameter on the mantle, we applied more or less the same parameter that we identified for the Berluccius. So you can see the overall tissue structural organization, the fiber bundle, detachment and gaping that is quite different from the other one, and it's like a spacing between the muscle fibers, and then of course the presence of vacuolar empty spaces within the muscle bundles. About the morphometrical parameter, we chose only one parameter that was represented by the percentage of white spaces highlighted overall in the section that were caused mainly by the appearance of vacuolar empty spaces and the detachment or gaping between the muscle bundle. About the arms, the morphological parameters were split in two different kinds. So the first one considering only the axial nerve cord, so the central part where the nerve is located, and the other considering the longitudinal muscle surrounding the axial nerve. About the morphometrical analysis, we applied the same white space percentage, but after the subdivision of the nervous region in 4 different regions of interest that I highlighted in the slide. Quickly running to the results. First of all, about the overall structure organization of the mantle, differently from what it happened in the Molluscus, the overall structural organization didn't allow us to divide clearly all the frozen categories from the fresh categories. These are the fresh, tumble, fresh, and this is the domestic frozen that preserved the same overall structural organization of the fresh tissue. About the fiber bundles detachment, a clear separation between the fresh and frozen sample was observed, and this confirmed that the gaping among the group could be applied as a suitable parameter for the discrimination between fresh and frozen products. More about the presence of vacuolar empty spaces in the mantle. Again, there was a clear discrimination between the fresh and frozen, all the kind of frozen product, with the appearance of vacuolar lesion and empty spaces in all the frozen categories, between and within the bundle, the muscle bundles. Finally, about the white space percentage in the section of the mantle, it allowed us to find again a cutoff value for the discrimination between fresh and frozen that was set at first at 25%, but considering that the range of the white space percentage in the fresh tissue reached sometimes the 31%, we applied a second cutoff that was settled between 25% and 32% of white space percentage, associated with the presence of a clear vacuolization of the tissue and a clear gaping of the tissue. About the arm, the overall structural organization allowed us to define this time a clear cutoff between the fresh and the frozen. So all the fresh tissue, in all the fresh tissue, the organization of the structure of the nerve was preserved, even after the tumbling of the tissue. On the other hand, all the frozen sample appeared having an alteration, a partial or total alteration of the axial nerve structure. About the breakage and the vacuolar spaces within the nerve, they were observed, and again they were used to discriminate the frozen sample from the fresh sample, although in the fresh tumble, a relative high percentage of partial vacuolar lesion was observed, as you can observe here in the slide, also in the fresh tissue. Finally, about the morphological parameter that was applied for the evaluation of the axial nerve, no statistical differences were found within the different regions. Means that the freezing didn't lead to a clear discrimination and a clear and a significant increase of the total white space within the nerve, the axial nerve region. And this selected parameter was considered not suitable for setting an operational analytical protocol to be applied to isolated sample. In conclusion, all the selected parameters, with the exception of the percentage of white measured inside the axial nerve, were suitable for the discrimination of the freezing process. And the vacuolization and increase of empty spaces within the tissue section were confirmed as peculiar parameters and microscopical effect of freezing procedure. And the protocol proposed after validation could surely constitute a valid analytical tool to support the checks carried out by the veterinary service, and on the other hand, the self-control activities carried out by the the business operator that are ascertaining the conformity of the products. I thank you for your attention, and go ahead with any question that you have. Here you can find my email contact if you want other explanation.
Dear Dr. Lara Tinacci,